So the good news is that section 11.7 doesn't really present anything new because we really don't need anything new. We've got an abundance of tests to use. You got the limit comparison test, the direct comparison test. I wouldn't use this one as much unless it's something really easy that works out good. Ratio test, p-test. Now, when you're trying to decide what test to do first, p-test, that works out pretty nice. You know, if something's in the form of a p-series, great. Another piece of low-hanging fruit would be geometric series. Something's geometric series, you can tell really quickly if it's going to converge or diverge. In fact, if it converges, you can actually find its sum. Nth term test. In order for these series to converge, the limit of the nth term has to be 0. If it's not, then it diverges. Okay. One thing to be careful about is that the nth term can't prove convergence. Do not say, oh, it converges by the nth term test. You can't do that. After that, it's going to be a little bit more hit and miss. You know, like I said, I'm not a huge fan of direct comparison tests because basically it's easy for people to make a mistake with. But the limit comparison test, if you can write your summation or compare it to a series that's familiar as being a p-series or a geometric series, then the limit comparison test works out great. Ratio test. This is good for something that might have factorials. We saw a couple like that in section 11.6. The root test is, you know, something to a power, you know, some expression to say the nth power. That might be something, it would be an indication of a root test. Alternating series test, again, kind of self-explanatory. If you have, you know, -1 to the n times some other term, then you can start thinking alternating series. Integral test, your tip for this, that you should use this or consider this, is it must be something you can integrate. Something you can integrate. So if it's not something that looks easy to integrate, then skip that test. So telescoping series, this has to be something that, you know, cancels out when you expand it. That's going to be kind of unique. You're not going to see much of that at all. But, you know, it is something we covered. And the nice thing is that for telescoping series, you can actually calculate the final sum. So that's kind of cool. Let's apply these. Let's get going. Now, what I've done in the past, I've done like the 2-minute drill. And I asked you for 2 things. I asked you to give me a method or a test on how you could prove convergence or divergence, and then a guess, converge/diverge. And the way I graded these, you didn't have to show any work, just gave me the answers. The correct test was worth 3 points, and guessing, because that's what it would amount to a lot of times, guessing correctly over here was with 1 point. So really the emphasis is on knowing how to get started on something like this. What could you do? And a lot of these things have more than one possibility. So yeah, let's see if I can zoom in a little bit better. There. So for instance, this one, what kind of test would you use on this one?
P-test.
Yeah, p-test, right? P-test. But as I said, I would accept different answers. So I would also accept maybe the integral test. Because you could integrate that one, do it that way. Going to converge or diverge? Well, square root of 2, is that bigger than pi or no?
Smaller than pi, so p is less than 1.
Yeah, p is less than 1, so it diverges. So a lot of times in the past, I've taught this during fall season. So in honor of football, we call it the 2-minute drill. Let's take a look at this one. What's the way to do this one?
Root test.
Root test, I'd accept that. What else would be acceptable?
Geometric.
Geometric series, absolutely. What else? I guess what catches my eye is this ratio. This ratio is greater than 1, right? So the nth term test could be used. Because what's going to happen is you take a look at the limit as n approaches infinity of this ratio. And of the whole term, I should say. Is it going to go to 0? No, it's not. Other answers that would work would be the ratio test. Would work there. And you could probably integrate that as well, but I wouldn't suggest that one. But that one's going to diverge because these aren't going to 0. The nth term cannot be used with convergence. If you're getting the feeling that I get that answer a lot and that it frustrates me, then you're very perceptive. How about this one? Suggestions for this one?
Ratio.
Yeah, I'd use the ratio test. Now it's a little bit of a blend because you're looking at that, oh, I got a factorial here, but I get an nth power here. But you know what? Taking the root of a factorial would not work out too good. So I just do the ratio test. What do you think? Converge or diverge? Your guess. Earn yourself a point here.
Converge.
Converge. Factorial is going to grow faster than an exponential. So this is going to converge. Cool. Some other people out there. How about this one? What can we use on this one?
A P test.
Great question. Is this a P series?
No.
No. P series, just to remind you, is going to look like this. It's going to be the sum from n equals 1 to infinity of 1 over n to the p power. P series converges when p is greater than 1. Not p equal 1. P is greater than 1.
Can I ask
But
a
this isn't
question
quite
about
finished.
series?
About P series?
Yeah. What if it's like the same form you just showed, but there's something added in the denominator? We couldn't use it, right?
Correct. So for instance, let me see if I got one planned out okay or not. Yeah, like this one right here. The 456th root of n plus 1. All right, so you could rewrite that if you wanted to as a sum from n equals 1 to infinity of 1 over n plus 1 to the 456 power, or 1 over 456 power, like that. But that's not a P series. P series would just have a 1 here. You could kind of make it into a P series if you played around with changing the limits, but yeah, it's not a P series. You'd have to have just n to some power. So this doesn't count as it stands as a P series. But there are things we can do with this one. Any suggestions? Well, you could use the limit comparison test with a P series. And I guess the P series that I would choose would be n to the 1 over 456 power. All right, now that P series I know diverges, and I'm guessing that this one's going to diverge as well because they're really, really similar. You could also use the integral test because that's something that I could integrate. Trying to think what else. Well, those two are the only two that are standing out at the moment. But so the answer is P series has to be pretty specific. It has to be something of the form 1 over n to the p. Now, if you have a constant in the numerator or denominator and you factor those things out, it's still of that form. You just can't have a whole lot of other stuff.
Oh Lord.
Well, let's go back to this one. What do you think? What could I use here? Now,
Ratio
what
test.
a ratio test, I think, would have a limit of 1. I think a ratio test here would be inconclusive. You can check me on that and text me if I'm right. All right. What jumps out in my mind, and what you can try and condition yourself to do, is try and look past some of these constants, like the -1. If the -1 wasn't there, then I'd have 2n over 3n. And 2n over 3n reduces to 2/3. Now, if you're summing up 2/3, 2/3, 2/3 infinitely often, are you going to come up with something that's finite?
No.
No. These terms have to get close to 0 relatively quickly in order for this to converge, and it doesn't. So you can use the nth term test, and that's going to diverge. There might be some other tests you can use there, but I'm not seeing them. They're not jumping out at me. This one's kind of manufactured a little bit. What could you use here?
The root test.
Yeah. What catches my eye is I got something to the nth power. And when you're taking the nth root of something that has an nth power in it, the root test. Now, looking at what's inside, I'll have 3n plus something over 4n minus something. You know, it looks like it's going to be about 3/4. 3/4 squared is going to be less than 1. So I'm saying that's going to converge by the root test. Now, you're not given extra credit points for choosing the hardest test that you can find. So go for the low-hanging fruit. What's the easiest way to do this one?
P-series.
P-series. Yeah. Now, you could do the integral test. That's fine. But that's, P-series. And it's going to diverge. How about this one?
Alternating series.
Yeah, alternating series. Series. And that's going to converge. And actually, it's going to converge conditionally. Because the series itself is kind of like a p-series with p equal 1/2. So it's not going to converge absolutely, but this one. And keep in mind, you can think of that as 1 over e to the n or 1 over e to the n. There's a couple different ways you can think of that. There's really a lot that you can do with this one. Writing it this way, you use a geometric series. You could use, let's see, what else? Ratio test, root test. Both of those would work fine. You probably do the integral test. That would work fine. Integral test. So a lot of possibilities for something like that. And it's going to converge. Well, I'd go for the easiest one. Probably the easiest one would be the geometric series. You can just look at that and say, okay, yeah, it converges. So continuing down with our list here, kind of a wild one, n factorial to the nth power. Wow, I just can't imagine how fast that would grow. It grow really, really big. Over n to the 3n power. Man, that's a battle of the titans. not sure who's going to win on that one. Any thoughts? What would you use? What would you try?
By any chance, P series?
It's not a P series
It's not.
because you don't have the P series. First of all, couldn't have any of the stuff that you have in the numerator.
Oh, okay. I was
Could
just
you
And it also have to be a fixed number, not a variable power. Somebody else started to say something?
Could you fiddle with it a little and use the root test?
I think the root test might work.
Like you'd have to change some stuff, but
Let's
Right.
see. What the root test would get rid of the n and the exponents, and then you'd be left with n factorial over n cubed. Factorial is going to grow faster than a polynomial, so that one's going to diverge. So yeah, I think the root test would work good. The ratio test would probably also work really well on this one. Well, really well might be an exaggeration. Might work well, or it might work. I'm thinking about the n here. Yeah, I think the root test might work out better.
when you say like when you like n factorial grows bigger, I'm confused on exactly how does that conclude that it diverges?
Well, the numerator is going to get bigger faster than the denominator gets bigger. So
Right.
this term is not going to go to 0. And unless these terms go to 0 pretty quickly,
Okay,
then it's not going to sum up to anything finite.
I see. Okay.
Okay. Now a couple of 2 late additions here for me were this one. I made it a little bit more obvious, but if you're looking at this one, I mean, you could use the limit comparison tests, because more or less you can think of this as 2n over n squared, and then cancel out the n's, limit comparison test with 2 over n. And that's going to diverge. That'd be one way. But the other way that we're really thinking of when I wrote down this problem was the integral test. Why the integral test? Can you see how this would integrate? Why it's just screaming out to be integrated?
It's one of the trigonometric ones. I don't know which one.
No, not quite.
It's an
Because
easy
I got
sub.
a u substitution. U equals n squared minus 9. There's your du term right there. So it's screaming out. So that would diverge because you get a log term. Log of that as n approaches infinity would go to infinity. Less obvious is this one. This one here. Again, no, it's not a p-series. Great question. It's not a p-series because I have that plus 16. But you can do it with the integral test, because this would integrate to the inverse tangent. So you take the 11 out, it'd be the inverse tangent, would be how that would integrate. It's not quite a p-series, but you can use the limit comparison test with a p-series with, say, 11 over n squared. That's a convergent p-series, or 11 times a convergent p-series. And if you did the limit comparison test, I'm sure you'd find that that one converges. So there's kind of a quick little review of a lot of different series. And I hope that it shows you the different variety of things that you have available to you. What I want you to do now is I'm going to break you up into groups, and I want you to work on that handout that I gave you, and then we're going to do a Kahoot to follow this up. Okay, so what test can't you use to show the series diverges? You know, I think I screwed this one up. Sorry about that.
I was about to say.
No, because I think you can use all these tests. And you know what? The direct comparison test, I'm not so sure about that one. No, wait. This one's right. So let's take a look back. We had the series of what? 100 over n? The nth term test can show divergence, but it you know, the limit as n approaches infinity of these terms goes to 0. So the nth term test is inconclusive here. So yeah, I thought I was wrong, but I was merely mistaken. Good for me. All right. Hunter up front. All right. But do you understand what's going on with that first one? If your terms 100 over n, your terms have a limit as n approaches infinity of 0. But the nth term test is inconclusive for that. So, okay. So you can't show that it diverges. You can only show, well, let's see. Am I right on that? Oh, I'm getting so confused. Yeah, this doesn't show divergence of the series. Now, we do know that the series diverges. You can say that it's a p series, but we don't know that it diverges or converges just based on this fact. So yes, we're right there. Let's keep going. Let's bring in the dramatic music. Five seconds, get your answers in. So the idea was to answer most completely. You could use the geometric series test and the nth term test to show that the series diverged. Hunter, still up at the top. All right, big changes on the leaderboard. Let's keep going. There's only one right answer here. Five seconds. Yeah, limit comparison test. All right, looking good. Let's see where our leaders are at. Uh-oh. All right, we'll change the leaderboard. John W. up top. Let's keep going. Which one can't you use? All right. For this one, the 3 and the 10 can factor out in front. Square root of n squared is n. You don't have to worry about the plus or minus because we're dealing with positive terms. N equals 1 to infinity. Let's see. Let me take a look back at this. I tweaked this last night and this morning, and I'm not sure if I got this thing right. Let's see. To show the divergence of the following series, you can't use P-test, geometric series. Yeah, it's not a geometric series. Just not. You can integrate this. You can use the p-test. I probably should give, it probably should take the answers for the nth term test as well. I probably shouldn't have that one there. But it's just not a geometric series. So, all right. Oh, some big changes up top. All right, Spencer grabbing the top spot. Okay. I should have written down that problem. I didn't write it down. So, all right, let's take a look at the leaderboard.
It was 2 to the nth power divided by 4 to the nth minus 1, I think.
Thank you.
Yeah.
All right, so let's take a look at that. It's not a P series. Integrating this, man, good luck. It's close to a geometric series, but it's not quite a geometric series. That's why, if you can get rid of this, then it looks like a geometric series of 2 over 4 to the nth power. And we know that geometric series converges. So you can use that with a limit comparison test and get an answer pretty quickly with that, because you know that this is a convergent geometric series. So thank you. All right. Now I'll give you a choice here. I mean, we can finish this up if you want to do. I think there's we're halfway there, or we can just quit. I did want to do a little bit of review outside of this, but I know we're already past time. So if a few of you got things to do, places to go, I understand. You can just take off if you want to. But what works for you? And I'll put in a little overtime for you guys. You want to finish this, or you just want to go to a review? No one's saying anything.
Can we go to a review?
Yeah.
Yeah, let's switch to the review. This is fun, but gotta hit some review here. So let's see here. Am I still recording? I am. So good. All right. So I think your test starts all the way back in section like 10.3. Is that right? Let me take a look. I don't have my syllabus handy. Oh, where'd it go? I think the test starts in 10.3. So one of the things you should be able to do is sketch a graph in polar. And what I might do if I get a chance, this is a big might, is email you guys, some blank graphs, so that even if you don't have a printer, you can take the time ahead of the test to write it out nice and neatly. You should find the slope of a tangent line. For an equation in polar. So there's a formula for that. I'll let you look it up. Areas. Area of an enclosed region. This is more like, I think, 10.5. So we had one like in class where I had like r squared equals 4 sine of 2 theta, and r equals 2 or something like that, where these two figures enclosed a region and you had to figure out the area. Remember, that's 1/2 the integral of r squared between alpha and beta d theta. Let's see. Then there was that weird stuff on conics. You should be able to find the directrix, vertex, and focus of a parabola. You know, and a hyperbola. And an ellipse.
Professor Parent, the notes for that section where we started talking about ellipses and stuff, the only thing that's posted for the notes is like the sheet that says how to differentiate whether it's a parabola, hyperbola, or ellipse. It doesn't show the actual notes for the class.
Really?
Yeah.
Yeah, it's just one page.
Really? Huh. I'll have to look into that. Was it like section 10.5? Yeah, that was 10.5. What was this stuff? So I've got the notes still. So I'll have to take a look back and see if I can't figure out the problem, but I'll write myself a little note on that. Revisit 10.5. Okay. Which conic am I? I think we played a Kahoot like that, but the difference is on the test, you could have equations like, you know, x squared plus 8x minus y squared plus 12y equals 70. You could have something like that, or you could have something like r equals 8 over 3 minus cosine of theta. Either way, you should be able to identify the conic section involved.
First one's a hyperbola?
Yes, first one's a hyperbola. Any idea what the second one is? An ellipse. Sequences. You should be able to determine sequences. You should be able to write out several terms if they're written sequentially or recursively. A sub n plus 1 equals, let's say, 5a sub n over 3 plus a sub n, something like that. Now that's a recursive sequence. You should be able to write out the first 5 or so terms. Let's see, what else do we do? Is the sequence bounded, monotonic? I would ask these for sequences that are explicitly defined, not sequences that are defined recursively like that. And then a lot of testing. We did a practice of all the series that you had in terms of convergence or divergence, what tests you would use. So I can't test you, well, I could, but I won't. I won't test you on every different, test that we had. There's like 10 of them. I won't make you do out the whole test for all 10 possibilities. But what I could do is that 2-minute drill stuff that we did. Stuff like this, where I ask you for a given series to determine what test you would have and a convergence or divergence. So stuff like that. Now, there are going to be some for which I do expect all the work shown. So you should be comfortable with showing me your work on all those. One thing we didn't get to practice was the telescoping series test, or the telescoping series, how they collapsed, but that's in there as well. One last thing that we could do, you can find the sum of a series, find the sum of a geometric series. Find the sum of a geometric series. There's a formula for that. That's about it. You know, there's a lot on this test, but at least you had a chance for a little bit more of a review than we had last time. And Mimi's gonna be around. Mimi, you still out there? No, okay. But Mimi's got office hours tonight and tomorrow, and I'll be in my office hours half hour before class as usual. So I'll catch you on Wednesday, 12:30. So if you have some last minute panic questions, you're like, how do we do this? It's a good time to get some help.
For this review sheet that you just wrote down, could you put the sections next to each?
I don't know the sections off the top of my head. I mean, this is like at 10.4 or 10.5. Area of enclosed region. I think that's like 10.5 as well. Links. No, actually, it's actually 10.4. 10.4.
So sequence and beyond is basically chapter 11.
Yeah.
Everything before that is chapter 10.
Yeah.
Like, yeah, 10.4 or 10.3 and beyond.
So that's like 11.1. And let's see, this is 10.3. What's that? Well, no, it's not 10.3. Yeah, I'm not sure, Nash. I don't know all
That's
all
fine.
the sections by hand. Yeah, I don't think this one's 10.3. Yeah. Yeah, it's 10.5. And then this is 10.6. So hopefully it helps out a little bit. Okay, I've kept you much longer than I should. My apologies. Good skill. Good skill. Hang tough, you're almost done. And we'll see you on Wednesday. Any last thoughts? Let me check the chat.
Thank you so much for the review.
Oh, you're welcome. Thanks, Kamaya. Okay, have a good couple days. Study hard. We'll see you on Wednesday.
See ya.
Bye.
Bye.
One more thing, Jeff, before you go. Sorry. This is actually something on grading, I guess. It's just one of my notes says thanks next to it, and then it just says 0 out of 20. Just wanted to see if you can take a look at that.
Where?
I think it's one of the notes that I submitted before. It says thanks, Nash, but then it just doesn't have a grade next to it.
Send me an email. Send me an
Okay.
email. Tell me which notes, because I mean, that'll certainly narrow down my search. It'd be great.
Okay.
All right. Thank you.